Hi everyone, so this is the second lesson for topic 4.4 Newton's laws of motion. So we are going to continue the learning outcome we have in the previous lesson, which is how to apply Newton's law of motion to the linear motion for the particle, which has a constant mass and also applied by a certain constant force. Alright, so we are going to continue the part where we discuss about force in dimension but in different situation. Alright, so let's start with the lesson. Alright, so you will realize that the notes part for today's lesson is pretty short as well. So we are going to spend more time in the example. So it will be kind of similar in majority of the lesson under this topic because as what I mentioned in a previous lesson, right? So what we are learning, what we are doing in this chapter is basically a combination of the previous two chapters. So that's why it's like how do we combine all the ideas then apply in the different situation. Okay, so yeah, that's why the content basically we have learned. It's just that now is the application. All right. So let's try to look at a very quick recap on the some of the stuff that we will be using in today's example. Okay, so this is the part two for the force in dimension. So I hope that after this lesson, then after you actually go through the exercise, then you are familiar with how to use your F equals to ma and Suva formula together. So after this, then next week we'll proceed with the force in two dimension already, which is what you are doing now and then plus the part for the resolving. Okay, so that's the idea. Okay, so when there's more than one force acting on an object, the Newton's second law can be referred to the net force, or sometimes it's the words that we have used before, which is the resultant force. Okay, so that's why from the definition of the force is actually proportional to the product of mass and acceleration, right? So that's why the force here we are referring to like one single force. So if let's say we have more than one force, then what we will try to do is combine the force, right? So after we combine the force, then this is how we get the net force. Okay, so the law can be referred to net force equal to ma as well. All right, so this is the idea that we have used it in a previous lesson as well. So the force in one dimension that we look into for the previous lesson is like the horizontal motion, right? So for example, you try to combine the force when you drive the car and you brake the car. So after that, then you find the new acceleration. Okay, so it's going to be the same idea for today's lesson, but the situation that we will be looking at is the vertical motion, which is like free fall and then or you try to throw it upwards and it fall down, so things like that. Then after that, the normal reaction. Okay, so yeah, just some of the recap. So this is what we learned in topic one, I think around lesson three. Yeah, so we learned about vertical motion. So we know that any object that drops under free fall. Okay, so which means the only force that apply on the object is only the gravitational force, right? So it will has a acceleration of g is equal to 10 meter per second squared. Okay, so however, we'll be looking into the situation where the acceleration will be changed if let's say there's other force, for example, air resistance. Okay, all right, so this is the part for normal reaction. So we know that normal reaction is one type of the contact force, right? If you can recall from the lesson that we discussed about friction. Okay, so the normal reaction force normally denoted by R is the force on an object due to being in contact with another object or surface, right? So when we have a force that acts from the object to the surface, it's going to be the weight. So according to Newton's third law of motion, there will be an equal and opposite force. So that's why we have another force that apply from the surface onto the object. So this is the reaction force. Okay, so it is the force that acts on an object from the surface it is resting on. All right, so it will normally act perpendicular to the surface. So as what we have know previously, so if let's say the surface is a slanted one, so a normal reaction will be perpendicular to the surface as well. Okay, then after that it's the same thing. We are going to use the Suva formula to solve the idea where we have the constant acceleration. So which is the case where you have constant force, so that's why you have constant acceleration. because the mass will normally be the same, right? So F equals to ma. So if let's say the force change, then the acceleration will be changed as well. So if let's say we can use all these formulas, so which mean that the acceleration is constant, which means the force is constant. Okay, so for this chapter, right, you'll realize that you will have a lot of questions that deal with different direction, like whether it's positive or negative. So that's why it's important for you to denote where your, which is your positive direction. So that's why when you try to do your calculation, then you wouldn't have much problem on the, for example, the velocity and the displacement that you try to use, right? So it involves positive and negative, and it means different thing. So it will be very helpful if you try to do that when you want to combine the forces after that. Okay, so let's try to look at the example. All right, so we can spend some time to read the question first. So yeah, there is a parachutist. So the mass is 70 kg. So he falls out of an aeroplane from the height of 2000 meter and falls under gravity until 600 meter from the ground. Okay, then after that he opens his parachute. So a parachute provides a resistance of 2330 Newton. So question one is to find what is the speed when the parachutist actually reaches the ground. Okay, so let's try to represent all this information by using a diagram maybe. Okay, so all right, so we have this parachutist of a mass of 70 kg. So that's why, let me just try to draw. This is a particular, so this is the parachutist. Okay, so he has a mass of 700 kg. So that's why the weight is 700 Newton. Okay, so the question tells us that he falls out of an aeroplane from a height of 2000. So maybe this is where he falls down. Then after that, this is my ground. Alright, so we know that displacement, we talk about what is the change of position with relative to the original position, right? So that's why, which means this will be the place for 0. Okay, then after that, this will be my displacement 2000 meter when he reached the ground. Okay, then after that, the question tells us that he falls under gravity until 600 meter. So which means this is the 600 meter from the ground. So which means when we try to compare to the original position here, it's actually 1400. Okay, so it's here, it's like the 600 from the ground. All right, so this is where he opens his parachute. So I'm just going to draw like this. Yeah, so this is like after he opened the parachute. All right, then what happened is that the parachute provides a resistance of 2330 Newton. So that's why there is a force that avoid the motion here, which is going up. So the resistance is 2330. Okay, and the weight is still the same here. All right, so that's basically what is that meant by the question. So the question one is to find out what is the speed at which the parachutist is traveling when he reaches the ground. So which means I want to find out what is the V when he is here. Okay, so you should be able to see that there are two stages involved in this question. So the first one is when the parachute is not open yet. So the parachutist actually falls under gravity, right? So the acceleration that we have here is actually equal to 10 meter per second square, right? So this is under free fall. Then after that, what happened is during the second stage, he actually opened the parachute. Then after that, the acceleration is no longer 10 because now the acceleration is affected by the resistance as well. So that's why we need to find out what's the new A here. Okay, so that's the whole idea. All right, so now let's try to see is there anything that actually can help us to find what we need. Okay, so you see, right, if let's say I want to find the V here, then what's the thing that I have and what's the thing that I need? So I know that the distance between 1400 to 2000, it will be equal to my S, right? The change in position will be 600 over here. Okay, then after that, I have my S, I have my V. Then by using the force, I know that perhaps I can find out what is my A as well. Then I need one more variable, so which is either I have my initial velocity or I have my time. But you know that in this case, it will be impossible for me to get the time because I wouldn't be able to get it from the first stage. You get what I mean? So what we can find out in our first stage is actually my initial velocity for my second stage, because the initial velocity for my second stage is basically the final velocity of my first stage. Okay, so I hope that you can understand it. So let's try to look at this one. So he falls out from an aeroplane, so we can assume that the starting velocity is actually 0. Then after that, it falls until this stage, then we can find out what is my final velocity so that I can use it for my second stage. Okay, so yeah, I also has my s here, right? So 0, and then here is 1004. So in this case, you can see that since our a towards the ground is like positive, and we try to use 1400 as well, so in this case we try to denote that going down is our positive direction. Okay, so this is important later when we calculate the force as well. Okay, so let's try to solve for the first stage. So I have the u is equal to 0, a is equal to 10, s is equal to 1400, and I want to find what is my v. So the equation that I can use is v squared is equal to u squared plus 2as. Okay, so let's substitute. So 0 squared plus 2as. Alright, so from here I can get v squared is equal to 28000. So when I do the square thing, then I'll be able to get 20 square root 70 ms per second. Sorry, meter per second. Alright, so this final velocity is eventually the initial velocity for my second stage, right? So now I have my u already, but then I want to find my v, right? So I need to solve for my a first, because I need to have at least 3 variables so that I can solve the fourth one. So that's why how can I find the a is by using the force here. Okay, so we know that we can use the net force, or if you write F, it doesn't matter as well. So the net force will be equal to m times a, right? So what's the net force here? So remember, going down is our positive. So that's why the force that going down will be the positive one as well. So which means in this case, it will be 700 minus 2330. Okay, then equal to the mass is 70. Okay, so make sure that you are not using 700. This is the weight, so this is the mass. Okay, then 770 and a. So we want to solve the a. So we have 70a is equal to negative 1630. So from here, then I'll be able to get my acceleration is negative 163 over 7. Okay, so which is a possible answer. I mean, it's a logical answer as well, because when you move down, right? So you can imagine that if let's say you have a positive acceleration, so which means that the velocity is actually increasing, then why is that? So you want to open the parachutist. It's actually you want to slow down so that when you reaches the ground, the impact is not so hard, right? So that's why your acceleration supposedly to be a negative value, so you can try to slow down. Okay, so now we already have the u and we have the a, so we can try to find our v now. So the information, let's try to copy down. So 600, and then the u is the v for the first stage, and the acceleration is negative 163 over 7, and I'm finding my v. Okay, so the same formula, I guess. So v square equal to u square plus 2as. Okay, so I'll be able to get u square plus 2a and then s. Oops, I'm sorry. I think so it's okay, I try to write. Okay, this is my a, this is my s. Negative 163 over 7 and 600. Okay, so after this, then I'll be able to actually solve it. So v square is equal to 400 over 7. So when we try to square root it, then we'll be able to get 7.53 meter per second in 3 significant figure. Okay, so I hope that you can understand the idea. So basically, it's about you need to understand the question and to understand that whether you can try to put them into a first stage or not. Same stage or not. So the thing that you need to consider is that whether in the stage itself, you have how many different acceleration that you are having. So as long as your acceleration is not constant, then you cannot put them in one single equation already. So what do you need to do is you need to divide them into 2 stages. Okay, so that's the idea. All right, so let's move on to example 2. Okay, number 2, part A, a ball of mass 0.2 kg is thrown with speed 8 meter per second vertically upwards of a window 4 meter above the ground. So assuming that there's no air resistance, find how long it takes to hit the ground. Okay, so which means we are finding the T. So by looking at this question, they tell you that there's no air resistance. So that's why the only force that acts on the object will be the gravitational force. So that's why you will have a constant acceleration. So what we are going to do is just by using a normal Sulfite formula, then we'll be able to solve it already. Okay, so yeah, let's try to draw it maybe. So you have this window. So this window is the place where the ball is actually thrown upwards, right? Then after that, it reaches here. Then after that, it falls down. Okay, so a question tells us that the height of the window, which is 4 meter above the ground, so which means from here to here is 4 meter. Okay, so yeah, so which means that we are just going to denote. So depends on you whether you want to do your positive direction. So maybe in this case we can try to do moving up is positive because initially it goes up first, right? So that's why going up is positive. It's okay, I can write down both. Okay, so if let's say we try to assume that going up is positive, right, then what happened here is that it's thrown with a speed of 8 meter per second. So this is speed. So if let's say going up is positive, so that's why our velocity here, which is the initial velocity, is going to be positive as well. So then for our acceleration, so we know that if let's say we try to state that moving down is positive, then it will has the acceleration of 10, right, of the gravitational acceleration. So now since going up is our positive direction, so that's why our A will be negative 10 then. Okay, so another information here that we have is we can use the displacement. So we know that displacement is like what's the change of the object here with respect to the original position, right? So this is the original position where it throw from the window. So going up is positive, so which means going down when the ball is actually on the ground is with a displacement of negative 4. Okay, so that's the first idea if let's say we try to put going up as positive. Okay, so the other way, if let's say going down is positive, so you can do either one lah. So depends on which one you prefer. So the other thing that you can try to do is if let's say the direction of going down is positive, so which means that when you try to throw the ball, you are throwing it up, right? So that's why your initial velocity will be opposite than your positive direction. So it's negative 8. Okay, but because of going down is positive, so that's why the A will be positive 10 lah. All right, so similarly, so this direction is a positive, so that's why your S is going to be 4. So no matter which set of value that you are using, so at the end you will be getting the exact same answer one. Okay, so we are going to find the time that it takes to hit the ground. So that's why S is equal to UT plus 1 over 2AT square. Okay, so the S here, we can use the first set maybe. So negative 4 is equal to 8t plus 1 over 2 negative 10t square. Okay, so when we solve it, then we can get a quadratic. So 5t square minus 8t minus 4 is equal to 0. Okay, so from here, then we can try to solve 5, 1, 2, 2, and then minus plus. All right, so we can get 5t plus 2 and then t minus 2. So from here, there's two value for t, which is negative 0.4, which is 2 over 5 and 2. Okay, so t must be greater than 0, so that's why t is equal to 2 seconds. Okay, so this is a question where you have like the constant force lah. So which means the only force from the beginning until the end is the gravitational force only. Okay, so now part B, if instead there is a constant of air resistance of 0.1 against the direction of the motion, find how long the ball takes to hit the ground. Okay, so now we might need to draw a new diagram here. So which means it's the same thing. So we have the window. Oops, I'm sorry. For this one, you might need to cut your section into halfway because I scared that the space is a bit small. Okay, so that's why I try to save some space over here. Okay, so you have this part. So the ball try to throw up. So it's like going up here. Then after that, it reached a certain point. Then same thing takes to hit the ground as well. Okay, so from the window to the ground. So this is also 4 meter. Okay, so something that's interesting for this part is that I mean accept the gravitational force, then you have the air resistance. So what happened here is you can imagine, right, when you try to throw it up, the weight is actually acting downwards. Am I right? So this is like your first force. Then after that, because of you have the air resistance, so what happened is the motion is going up. So the resistance avoid the motion. So that's why your air resistance is actually moving down as well. Am I right? Because you are throwing it up. But what happened when your ball actually reach the maximum position and it starts to actually fall down? So is that your motion now is going down, then your weight is also going down, right? But the resistance is going to oppose your motion of going down, so that's why your resistance will be going up here. So you realize that this is a question with two stages as well. The first one is that your weight and resistance is actually moving towards the same direction. Then the second one, they are different direction. So if let's say you have a different net force, which means the acceleration is different. So if the acceleration is different, then we cannot solve it like how we solve A, which is to just put them everything into one equation. Okay, so that's the idea. Okay, so what do we need to do now is maybe we can try to find out the going up first, like what's the net force and then what's the acceleration here. Okay, so the first part is when it's going up. Okay, so same thing, we have the net force is equal to our mass multiply the acceleration. Okay, so we can try to denote whether you want going up is positive or going down is positive lah. So in this case, since we are doing different stage, right? So that's why it's easier for us to denote that going up is positive. So if let's say going up is positive, right? So which means our force must be in that direction as well. So the net force going up is positive. So which means both weight and resistance will give me a negative force. So that's why it will be negative 2. The weight is 0. The mass just now is 0.2. So that's why when you multiply by 10, then this is how you get your weight as negative 2. Then after that, minus off the air resistance, right? So minus 0.1 as well. Okay, both negative because going up is positive. Then equal to our mass here is 0.2 and the acceleration is what we want to find. So negative 2.1 is equal to 0.2a, which can give me a is equal to negative 10.5 meter per second square. Okay, so after I have got this, then how should I continue? Yeah, because the question wants us to find how long the ball takes to hit the ground, right? So if this is the first stage and this is the second stage, then I might need to find out what's the T1 here. Okay, then which means that by using some of the information here, so similarly, my U here will be like what has stated in my section A, which is the 8 here. Okay, so equal to positive 8 because going up is positive, right? Then after that, I have this is the maximum position. So that's why when the ball reach the highest position, then the final velocity is 0. Then we have the acceleration which is negative 10.5. So now we can proceed to find the t. Okay, so let's try to solve it. So u v a t, so we can try to use v equals to u plus a t. So v0 8 plus a and then t. So make sure that when you try to put in, if let's say you get your t a negative value, then that's something that you need to be mindful of. Okay, so when you try to solve it, then you can get 16 over 21. If in decimal, then it will be 0.762 seconds. Okay, so this is for the first time here. Alright, so now we already find out this is the time that we spent for the first stage, right? So now let's try to sort out the second stage. Okay, so for second stage, it's going down. So since it's a different equation. So that's why for the positive part, you can actually change it. I mean, it doesn't matter whether you still use going up as positive or not. So because you are actually doing an entire new equation, right? So that's why, since this is our direction, so it will be easier for us to just change going down to be the positive. Okay, so now we are trying to look at the stage which the ball is going down. Okay, so what's the information that we have here? So the final velocity of the first stage is zero, right? So that's why the initial velocity will be zero as well. Okay, then after that, can we find the acceleration? We can, right? Because we have these two force. So that's why the net force is equal to ma. So the force here, then because going down is your positive, so that's why W is positive and then the R is negative. Okay, ma, so the weight is 2 minus the air resistance 0.1 equal to mass 0.2 and 8. So when you solve it, then you'll be able to get positive 9.5 meter per second square. Okay, so now we also have our acceleration. Okay, so what else do you have? So we need to find t, right? So you have two choice. Either you have your final velocity, what's the velocity when the ball hits the ground. Then the other thing that you can have is your distance. What's your distance from this position to this position? So what is the variable that you can actually find it from the first stage? Do you think you can find the final velocity? The final velocity has no relationship at all with your first stage, right? So that's why you can't do that. But can you find the S? If let's say you can find the S for the first stage, right? What does that mean? So which means the total displacement for your second stage, it will be your S1, which means the distance when you try to throw from the window until the highest position, then it will be this distance then plus the 4 meter from the window to the ground. Am I right? So it means from here to here is S1, then from here to here is going to be 4. So that's why we need to find our S from the information for our first stage. Okay, so how do we do that? So we can try to use the similar thing that we have. So from the first stage, okay, and we try to find what is our S1. Okay, so UVA, and we can try to use V square equal to U square plus 2AS. So let's substitute. So V square is 0, then 8 square plus 2A and S1. Okay, so from here, then I'll be able to solve S1 is equal to 64 over 21. So it's around 3.0476 and so on. Okay, so that's why the distance over here, it is 64 over 21. So now we can find our total displacement already. So which means our total S for the second stage, it will be equal to 64 over 21 and then plus the 4 meter from the window to the ground. Alright, so from here you can get what's your S, which is equal to, yeah, we are just going to write down like this. So okay, later we are going to substitute inside. Okay, so after we have this, then we have three variable already. So now we can proceed to find our T. So I think it's a bit messy here. So let me just write down the three variable first. So U equals to 0, A equals to 9.5. So let me just calculate for that. So we have 4 then 64 21. Okay, so is S is equal to 148 over 21. Okay, so after we found this, then we can proceed to find our time now for the second stage. Okay, so S will be equal to UT plus half AT square. So 148 over 21 is equal to 0t, so 0 half 9.5 t square. Okay, so I'm not going to solve everything out. So it's basically you have this, then you just divide lah. So t square, t will be equal to 1.218 second. Okay, so this is my second stage. So our total time then it will be both try to add up together, because this is the time that you move the highest position, then this is the time that you spend to reach the ground, right? So that's why 0.6, let's try to use the exact value, 16 over 21 plus 1.218. So three significant figure, then we can get 1.98 second. Okay, so I hope that you can understand the whole idea. Yeah, it's the same thing like question one, also two stage, but now it's just that it's a bit difficult because it's like going up and then going down. So the idea is like what I say lah, you need to understand that whether it's travel in a constant force or not. So if the force is not constant, then which means the acceleration change. If the acceleration change, so that you need to split it into two stages to help you to solve the question. Alright, so this is a two question for vertical motion, and now for number 3, 4, 5, we will be looking at the normal reaction. Alright, so I guess compared to the vertical motion, the normal reaction will be easier, but the only thing is just, it's still the same thing now. Make sure you denote your positive, negative, so that when you do your force, you know which one is positive, which one is negative, following the same direction. Okay, so a girl of a mass 45 kgs is sitting in an aeroplane, so helicopter, I'm sorry, like how come aeroplane? Okay, so this is the girl. Okay, so the mass is 45 kg, so 4504 weight. Okay, the helicopter rises vertically with a constant acceleration from rest to speed. So from rest and then to speed of 40 meter per second when it reaches a height of 200. So we assume that the displacement is at 200. Okay, so the question one is to find the normal contact force on the girl. So this is the weight, so the normal contact force will be over here lah, right? Okay, so for in this case, then you can, I mean, decide yourself. So since the question gives us it rises vertically, right? So it will be easier for us to just follow the motion that going up is positive. Okay, then you might need to check lah. If let's say going up is positive, so that's why from rest to a speed, so this is positive, that's correct. So going up is positive, so reaches a height of 200, so this is positive as well. Okay, so now let's move on. So what we have here is UVS, and we want to find the R here. So which means we might need to get what is our acceleration from this question. Then we only can use net force equals to mass multiply MA to find out what's the normal contact here. Okay, so let's try to find the acceleration. So we have UVS, so we can use, we want to find A, so we can use V square equal to U square plus 2AS. So 40 square equal to 0 square plus 2AS. Okay, so from here, then I can get my acceleration is equal to 4 meter per second square. So after I found this, then which means I can try to substitute already. So net force is actually equal to m times a. So what's the net force in this question? So remember, going up as positive, so that's why the normal force is positive and the weight is negative. So that's why it should be R minus of the weight. Okay, and it is equal to the mass, which is 45 kg, and multiply the acceleration, which is 4. So R is equal to for this one plus 450, so you can get 1318, so 630 Newton. Okay, that's right. Alright, so that's the answer for number one. I think this is pretty easy. Yeah, so what is important, like what I said, is the direction. So you make sure that after you denote this, then your force should be according to this as well. So which means then if going up is positive, so the force going up will be positive also. Okay, number 4. Okay, a drone carries a parcel of mass 4 kg. The parcel is held in place by two pads on its top and on its bottom. Okay, so let's say this is our parcel. Okay, so what happened now is it's held by two pads, so one at the top, okay, then one at the bottom. Okay, sorry, it's a bit ugly, but it's okay. Okay, so the what happened here is the parcel has a mass of 4 kg, so that's why it has a weight of W is equal to 40. Okay, so the drone hovers at a height of 30 meters, so which means the parcel is now at here, maybe 30 meter, before descending for 2 seconds. So it's going down. Sorry, let me redraw it again. Okay, so it's descending for 2 seconds, then until the height of 8 meter. Okay, so find the normal contact force that acting on the parcel. So determine whether the force is X from the top pad or the bottom pad. Okay, so the idea is like this. Let me try to draw it whole. I think I can. Yeah, that's right. Okay, so this is my parcel. So we can imagine that if we try to recall from the definition of contact force, right? Oh, sorry, from normal reaction force. So it's one of the contact force is actually exists when you have one object get in contact with one surface. So that's why we know that this surface get in touch with the object. So you have one normal reaction force is from the bottom pad from here to here, right? So this is like one normal reaction force. Then you have the other one from the top surface to onto this object as well. This is your second reaction force. Okay, so that's why in this question they want to find out ultimately. So when we try to treat the normal contact force as a whole, so which one is going to give you more force? That the force is actually X from that one. So which means if for example this is giving 8, then this is giving 4, so which means at the end then you will have a total of 4 only, which is from the top. Okay, so that's the idea. So which means that we are not going to find them in separate way. Okay, so in this case then what do we need to find? So since that we are given I think let's try to find some of the information that we have first. So we know that the drone hovers. So hovers meaning they stay at the same position. So which means they just remain at the same height. Okay, so that's why what happened here is your initial velocity is going to be 0 because there's no change in position, right? Then after that, the question tells that it's descending for 2 seconds. So that's why the time might be 2. So it's descending from the height of 30 meter to 8 meters. So that's why the total displacement, the change in the displacement is actually 22. Okay, so since it's going down, so we can just try to treat that going down as is our positive direction. Okay, so we can find our acceleration. Then after that, same thing, we try to use the net force formula to help us to solve this. So to find our acceleration. Okay, so remember to check it out whether your direction, everything is aligned to the position that you assign or not. Okay, so in this case, yes, then we can straight away try to use the formula. So S equal to UT plus half AT square. Okay, so U is 0 and then plus 1 over 2. A is what we want to find. Sorry, 22 here, then T square is 2 square. So from here is 22 will be equal to 4, so 2a, so our acceleration is 11 meter per second square. Okay, so by having this, then now we can try to solve for this one. So it would be depending on you whether you want to, because we are trying to look at it as a whole, right? So that's why either you can try to do going up. Okay, we can try, I'll show you both. So the first one is we try to imagine as if let's say the normal reaction is acting upwards now. Okay, then after that, the other one is I try to imagine the normal reaction from the top pad is actually higher than the lower. So that's why the resultant for R is going this way. Okay, so we can actually work out both. Okay, so now let's try to see what happened if let's say we try to do the orange color one. Okay, so we have our acceleration already. So going down is positive, right? So that's why if we are trying to solve the orange color one, so which means now what I have is my W will be positive. Okay, and then minus of the negative, which is R, because the R here is going up. So it will be equal to the mass for this question is 4. Then after that, the acceleration that I found is 11. Okay, So now let's try to substitute. So 40 minus R, it will be equal to 44. So that's why I will get my R will be equal to -4. Okay, so you see, my R here is -4. So what does that mean? So which means I can always change the direction, right? If you can remember in the resultant. So if let's say now our resultant is negative going up, so which means it's the same thing also. If I say is R equal to 4, then I try to change the direction going down. Okay, because -4 is going up. So if I try to change the direction, then I will just negative my answer lah. Okay, so if let's say I try to use the green color, which means that I already, I guess that the top pad actually give a bigger normal reaction. So that's why going down is positive, right? So both of these will be positive. So that's why W plus R is going to be equal to MA. So when I try to solve this, then I will get 40 plus R is equal to 44. So my R will be getting +4. So that's why by looking at this direction, it's +4. This is going down, right? So that's why you can see both of these uh, approach is going to give you the same answer. It's just that one is negative going up, so you change it to +4 going down. So the other one is like you straight away can get the answer by having a positive answer lah. Then it's in the correct direction. Okay. So alright, so this one is going down. So the question want to ask is X from the top pad or the bottom pad. So that's why the normal reaction is going down, which means it's the normal reaction that created by the top pad. Okay, so going down, then the force is from the top pad. Okay, so remember to answer the question like specifically. Okay, so now let's try to look at the very last question. All right, number 5, a crane is lifting a pallet. So on the pallet, it rests a stone block of mass of 5 kg. So you have a crane. I don't know how to draw, but yeah, I mean, this is like the crane. Okay, so yeah, you have like something that's going to be something like this. Okay, then I try to take out. Okay, then this is like the crane that you have on the floor. Okay, so on the floor itself, so there's a stone block here. Okay, so the block is like 5 kg. Then what you are trying to do is like pulling it going up lah. Yeah, so I mean it doesn't work like this. Maybe my drawing is a bit okay. Yeah, but basically the something is, oh yeah, maybe like this. Okay, it's trying to pulling it up. Okay, so now we have the mass of 5 kg. So that's why this thing is going to create a weight of 550 Newton. Okay, so the motion is vertically upwards, so which means that what the crane is trying to do is lifting it up. So that's why in an easier course, then we can just try to make going up as positive. Okay, so the crane lifts the pallet from rest to a speed of 3 meters per second. So since going up is positive, so that's why the initial velocity is 0, then the final velocity is 3. So in 6 meters, so that's why the total displacement is 6, positive as well because going up as positive. So if you want to put going down as positive, then which means then it will be negative and negative lah, because these two is going up, right? Okay, so find the normal force on the stone block during the acceleration. So which means what is the reaction force here? So similarly, which means that we need to find our acceleration, then only we can try to find the force. So we have UVS, then we can find our A, right? So by using V square is equal to U square plus 2AS. Okay, so 3 square is equal to 0 square plus 2AS. So 12A, 9, and A will be equal to 3 over 4, which is 0.75 meter per second square. Okay, so since we have the acceleration already, so we can try to use the net force. So net force will be equal to M times A. Okay, so yeah, what's the net force here? So we have the weight and the reaction force, right? So remember our direction going up is positive, so that's why the resultant force here is positive as well. So R will be minus off the weight, which is 50, then the mass here is 5, then A is 0.75. Okay, So by solving this, then we can get our R will be equal to multiply this, then I can get 3.75, so 53.75 Newton. Okay, so I hope that this is still easy. Yeah, so basically it's just the same thing to solve for the A, then you try to substitute. Okay, so now B, if the normal contact force exceeds 650 Newton, the pellet may break. So in this situation, it's considered unsafe. Okay, so assuming that they are having the same acceleration as in part A, so which means the acceleration here is going to be 0.75 as well. Find how many stone blocks the crane can lift safely. Okay, so which means in this case, let's try to just draw the crane. Sorry, just draw the pallet. Okay, so this is like the block that you are putting on it, right? So which means now we don't know how many we can put on it, but we know that one block is basically equal to 5. So we can imagine that let's try to put less the number of block Bn, small n maybe. Okay, so to be the small n, so now we want to find out how many that we have. So you can imagine if now we have each of it, so we don't know how many we have, right? So one mass is like 5 kg. So that's why I know that the total mass here will be just equal to 5n. Am I right? Because I don't know how many much. So if let's say I have 3, then it's going to be 3 times 5 and so on. So that's why the weight here will be 5n times 10 lor. So which means it's going to be 50n. Okay, then the normal reaction cannot exceed 600. So which means the going up part. So it must be less than 650. Okay, so that's the idea. So which means now we can straight away solve it, I guess. So let's try to denote our positive direction. So I think since we use A is positive here, so we just continue whatever that we do in part A. So going up is positive. Okay, so net force will be equal to M multiply A, right? Okay, so the net force here going up is positive, so that's why the resultant here is going to be positive and minus off the weight here, which is 50n. Okay, and it will be equal to the mass, which is 5n, and the A here is 0.75. So from here, then I can try to solve it, and I can get R will be equal to 3.75n plus 50n. So from here, then I can get R will be equal to 53.75n. So that's the equation that I get. So from the question, we know that the R cannot exceed 650, right? So that's why we are trying to find the maximum number of blocks that we can put it on. So that's why the R must be lesser than 650. So we try to substitute and we try to find it out. So 53.75n should be lesser than 650. Okay, so by using your calculator, 650 divided by 53.75, so we should be able to get 12.093. Okay, so we are getting maximum, so which means the number of blocks that we can put must be lesser than 12.093 so that it wouldn't create a normal reaction force of 650. So that's why the maximum number that we can put, max n. Okay, the maximum number for n that we can put is 12. Okay, so that's the idea. All right, because it cannot more than 12.093. So that's why when you put up 12, it's still going to be lesser than that. Okay, so that's it for this question. I hope that you can understand the idea, then try to do some of the question. So yeah, because this is like the basic, must make sure that you can actually understand and handle all this before we move on to the harder example or the real past year questions that involving resolving forces also in the future lesson in next week. Okay, so that's it for today's lesson. Thank you.